depending upon the wavelength of the light rays, the bending will be there, the deviation will be there. So basically prism is doing two jobs. First is the dispersion and second is the deviation. Already in our previous lecture we studied about the deviation of light. So today we are going to study the dispersion of light by a prism. So basically dispersion of light you can see from this picture. Already in your earlier classes, in your class 10th, you have studied that when the white light is passed through a prism, it gets split into 7 colors, with red color at the top and violet color at the bottom. Means the bending of the red color is least and the bending of the violet color is maximum. This is called dispersion of white light through the prism. Light can be dispersed through many objects, like even a water drop present in the atmosphere that can also behave like a prism. You must have seen the rainbow, must have seen the primary rainbow, the secondary rainbow. So basically that is happening not through the prism, that is happening through the water droplets present in the atmosphere. So the water droplets, they are behaving like a prism. So prism action, it is not compulsory that it can be done with the help of a prism only. It can be done with the help of a water drops. Even it can be done with many objects, right? So the basic purpose of the dispersion of light is to split the light into its constituent colors, into its constituent wavelengths. That is called the dispersion of light. Now, why the different colors they are dispersed and why the violet get maximum bending and red get minimum bending? It is due to the refractive index of a prism, because refractive index of a prism is different for different wavelength. Refractive index is maximum for the violet light and refractive index is minimum for the red light. That's why the bending of red is least and bending of violet is maximum. It is only due to refractive index of the prism. Refractive index of a prism is different for different wavelengths. For red has its own wavelength, 750 nanometer. So refractive index is different for 750 nanometer, and violet has 360 nanometer. So refractive index of the prism for 360 nanometer is different. Now from this diagram, you can see when the white light is made to fall on the prism at any point, then actually it should go straight if there is no prism in the path of light. But because of the presence of the prism material, the light bends. So here at this point, you can call this point as point P. So let me write this point. This is a very important point. This point as P. So you see at the point P, two things are happening. The first is it is the deviation. It is the deviation which is happening at the point P, means bending. And second is the dispersion. Dispersion means splitting of white light into 7 colors. So the point P is very important. At point P, दो चीजें हो रही हैं. एक डेविएशन का मतलब मुड़ जाना अपने पाथ से, और डिस्पर्सन का मतलब स्प्लिट इनटू 7 कलर्स. सो इस पॉइंट पे दो प्रोसेस हुए, एक हुआ डेविएशन, एक हुआ डिस्पर्सन. तो यू कैन सी डेविएशन एज वेल एज डिस्पर्सन. सो आई ऑलरेडी टोल्ड यू, रेड कलर सबसे ऊपर होगा, रेड कलर का डेविएशन सबसे कम होगा, वायलेट कलर का डेविएशन सबसे ज्यादा होगा. अब हम अगर एक लाइन ड्रॉ करें बैकवर्ड फ्रॉम द रेड कलर एज वेल एज फ्रॉम द वायलेट कलर, तो रेड कलर की जो लाइट है दैट विल मीट द expected path. This is the expected path of the ray of light in the absence of the prism. But क्योंकि prism आ गया तो ये path trace नहीं होगा. The light will go through these path. So ये expected path है in the absence of the prism. So इस expected path के साथ अगर red color को backward produce करें, so red color will meet at the point Q. So now, what is delta R? It is the deviation produced by the red color. Now it is the angle between the expected path and the actual path of the red color. So this is delta R, deviation produced by the red color. So what is delta R? Delta R, it is deviation produced by red color. Red color. Now take a line and just take it backside from the violet color, and it will meet at this point, and you can call this point as point R. इस point का नाम रखो R. अब देखो expected path ये है और violet का जो line है वो ये है, and this angle is called delta V. So delta V basically it is deviation by violet color. Now we are interested in this angle theta. So what I will do, I will take the point Q even in the back side. Similarly, I will take the line from the point R even in the back side, and they will meet at this point. So take this point as S, and they are subtending an angle theta. So this theta is called angular dispersion, which is important for us. This is angular dispersion. Now our target is to find out this angular dispersion. So you can see from this whole geometry, if I subtract delta V minus delta R, then I will get this theta. So theta is nothing else, but it is the difference of delta V and delta R. So our basic purpose is to find out angular dispersion. So angular dispersion that can be found with the help of this formula. So theta is equal to delta V minus delta R. So let us show you with the help of my slides all these things. So our target is to find out theta, and this theta is called angular dispersion. Now how we can find out the angular dispersion? Already I told you, basically theta is equal to delta V minus delta R. So this theta, it is equal to delta V minus delta R. So it's very simple to find. Theta is equal to deviation produced by the violet color minus deviation produced by the red color. It is from the geometry. Now we know that deviation of violet color, it is delta V, deviation of red color is delta R. Here one more important thing, it is the deviation of the yellow color, because yellow color that lies between violet color and red color. So it is also called, the yellow color is also called mean color. So this delta Y is called mean deviation. Delta Y lie करेगा violet और red के बीच में, वायलेट और रेड के बीच में येलो कलर लाई करेगा. सो येलो कलर की भी अपनी डेविएशन होगी, उसको हम बोलेंगे डेल्टा वाई. अब क्योंकि बीच में है तो इसको इसलिए डेल्टा वाई को बोलते हैं मीन डेविएशन, राइट. सो इट इज कॉल्ड द मीन डेविएशन. सो अब हाउ टू फाइंड आउट डेल्टा वी. डेल्टा वी हम पहले ऑलरेडी प्रिज्म फार्मूले से निकाल चुके हैं. सो प्रिज्म फार्मूले से डेल्टा हमने निकाला, डेल्टा इज इक्वल टू म्यू माइनस 1 इनटू ए, वेयर म्यू इज द रिफ्रैक्टिव इंडेक्स ऑफ द मटेरियल ऑफ द प्रिज्म, A is the angle of prism. So डेविएशन निकाल चुके हैं. अब हमें यही डेविएशन वायलेट के लिए निकालनी है. तो वायलेट के लिए करेंगे डेल्टा V is equal to mu V minus 1 into angle of prism. Likewise we will do for the red color. So deviation for the red color is equal to mu R minus 1 into A. Likewise deviation for the yellow color is equal to mu Y minus 1 into A. Now angular dispersion we know it is delta V minus delta R by using this formula. Theta is equal to delta V minus delta R. So by using this formula, now putting the value of delta V from here and delta R from here, ये -1 और ये +1 हो जाएगा. कि जब माइनस करेंगे तो ये प्लस हो जाएगा, तो 1 1 कैंसल and we are left with mu V minus mu R into A. So angular dispersion theta is equal to refractive index of the violet color minus refractive index of the red color multiply angle of prism. So this is basically the angular dispersion produced by a prism. Now, what is the moral of the story? You see, if we have a very thin prism, for a thin prism, angle of prism is also very small. So let me show you. अगर एक मोटा प्रिज्म है, तो उस प्रिज्म में एंगल ऑफ प्रिज्म ज्यादा होगा, ये वाला एंगल ए एंगल ऑफ प्रिज्म. बट अगर थिन प्रिज्म है, थिन प्रिज्म के अंदर ये एंगल छोटा होगा. ये थिन प्रिज्म है, सपोज करो ये एंगल ए डैश हो गया. ये थिन प्रिज्म एंड दिस इज थिक प्रिज्म. सो थिक प्रिज्म में एंगल ऑफ प्रिज्म ज्यादा होगा और थिन प्रिज्म में एंगल ऑफ प्रिज्म कम होगा. सो अगर थिन प्रिज्म है तो ये एंगल कम होगा, ये एंगल कम होगा तो थिन प्रिज्म के लिए थीटा भी कम होगा. मींस एंगुलर डिस्पर्जन थिन प्रिज्म के लिए कम होगा, राइट. बट थिक प्रिज्म के लिए एंगुलर डिस्पर्सन ज्यादा होगा, मींस थीटा ज्यादा होगा, राइट. नोट कर लिया ये.
Yes, sir.
Now the second topic is the dispersion power, or it is also called dispersive power. Dispersive power. So it is represented by omega. So what is the definition of the dispersive power? So dispersive power, it indicates the ability of the material of the prism to disperse the light, to split the light into 7 colors. So it is the power of the prism to disperse the light. If the prism is very good, so dispersion will be very good. If the material is very good, the dispersion will be very good. Means properly all the 7 colors, they will be separated. But if the material of the prism is not good, then dispersion definitely it will not be good. So might be possible that all the 7 colors, they may blend. They may not be separated properly from each other. They may be blend. They may be mixed. So if the prism material is very good, then all the 7 colors, all the 7 wavelengths, properly they will be separated. But if the material of the prism is not good, then might be possible that the colors, they may mix together. It will become very difficult to see them separately. So it is the dispersive power which represents the separation of all the colors within the prism. Now, how to find out this omega? Already we know the deviation produced by the prism, that is represented by delta m, and one more formula which is the angular dispersion, theta is equal to delta v minus delta r. ये हम निकाल चुके हैं. थीटा ये बेसिकली थीटा है. थीटा इज इक्वल टू डेल्टा v माइनस डेल्टा r इज इक्वल टू म्यू v माइनस म्यू r इनटू a. अभी हमने कैलकुलेट किया. सो ये भी फार्मूला हमें पता है. रिफ्रैक्टिव, ये दिस इज कॉल्ड प्रिज्म फार्मूला. ये प्रिज्म फार्मूला भी हमें पता है. n/1 refractive index of the second medium with respect to first medium is equal to angle of prism plus minimum deviation divided by 2 and a by 2, right. दोनों फार्मूले हमें पता है. ये एंगुलर डिस्पर्जन, ये प्रिज्म फार्मूला. ये एंगुलर डिस्पर्जन डेल्टा v minus delta r is equal to mu v minus mu r into a, and this is the prism formula. n/1 is equal to a plus dm. This dm is called the minimum deviation divided by 2 and a by 2. अब इसको रीअरेंज अगर करें प्रिज्म फार्मूला को, सो we will find वापस चलते हैं एक मिनट. अगर इसको रीअरेंज करें सो एक्चुअल में हमें जो मिनिमम डेविएशन मिलेगी वो ये मिलेगी. मिनिमम डेविएशन जो मिलेगी ये मिलेगी dm इज इक्वल टू n/1 a minus 1, और यहां से a कॉमन निकाल देंगे. a अगर कॉमन निकाल देंगे तो हमारे पास क्या बचेगा, n/1 minus 1 into a. दिस इज कॉल्ड डेल्टा m. सो ये मिनिमम डेविएशन निकाल दी हमने. सो मिनिमम डेविएशन भी एंगल ऑफ प्रिज्म के ऊपर डिपेंड करती है. अगर थिन प्रिज्म है तो डेविएशन भी कम होगी, अगर थिक प्रिज्म है तो डेविएशन भी ज्यादा होगी. सो कीप इन माइंड दिस फार्मूला which is from the angular dispersion and this formula which is from the prism formula, and by rearranging the prism formula, finally we will get minimum deviation is equal to n/1 minus 1 into a. राइट। अब हमें तो ओमेगा कैलकुलेट करना है, हमारा टारगेट तो ओमेगा के लिए है। सो फाइनली ओमेगा पे चलते हैं। ओमेगा कैसे निकलेगा, देखो ये ऑलरेडी हम निकाल चुके हैं। dm इज इक्वल टू n टू 1 माइनस 1 इंटू a, राइट। सो यहाँ इन्होंने ओमेगा कोई कैलकुलेशन नहीं है, ओमेगा को डायरेक्टली बेसिकली डिस्पर्जन के लिए ही यूज किया गया है, और ओमेगा का कोई प्रॉपर डेरिवेशन नहीं है, कोई प्रॉपर फार्मूला नहीं है यहाँ पे। तो अब इसको मैं अपने तरीके से कैलकुलेट करता हूँ, हाउ वी कैन फाइंड आउट ओमेगा। सो ओमेगा की जो डेफिनेशन होगी, ओमेगा इज इक्वल टू, दैट इज द रेशियो ऑफ थीटा एंगुलर डिस्पर्जन डिवाइडेड बाय मीन डेविएशन। मीन डेविएशन इज फॉर द येलो कलर। तो ये फार्मूला बना ओमेगा के लिए, एंगुलर डिस्पर्जन, नोट दिस फार्मूला, angular dispersion divided by mean deviation. Mean deviation means deviation for the yellow color. So mean deviation ये है, angular dispersion ये है। अब ओमेगा निकाल सकते हैं। So ओमेगा is equal to, थीटा हमें पता है, it is delta v minus delta r, और ये डेल्टा y। अब तीनों चीजों की वैल्यू प्लेस करेंगे। तो डेल्टा v माइनस डेल्टा ऑलरेडी यहां से निकाल चुके हैं। सो इट इज म्यू v माइनस म्यू r इंटू a, एंड व्हाट अबाउट दिस डेल्टा y? डेल्टा y को लिख सकते हैं, डेल्टा y इज इक्वल टू म्यू y। स्क्रीन शेयर हो रही है? खुशी स्क्रीन शेयर हो रही है?
Yes, sir.
ठीक है।
Yes, sir, हो रही है।
तो ओमेगा इज इक्वल टू, हमने निकाला डेल्टा v माइनस डेल्टा r डिवाइडेड बाय मीन डेविएशन येलो कलर के लिए, और डेल्टा v माइनस डेल्टा r की वैल्यू प्लेस कर दो, म्यू v माइनस म्यू r इंटू a, और डेल्टा y की वैल्यू रख दो, म्यू y माइनस 1 इंटू a। अब दिस a is cancelled, so finally omega is equal to mu v minus mu r divided by mu yellow minus 1. So this is our dispersive power of a prism, right? So angular dispersion and dispersive power, they are very important for the final examination point of view. So practice these and note both the topics in your notebook. So that's all for today.